Alright, today we're going to talk about classifying real numbers. So let's start off with talking about some definitions first. Some definitions that we have, alright? The first definition we have is a set. A set is a collection of objects or elements. Alright, the elements that we have are what makes up the set. Second definition we have empty set. So a specific type of set. An empty set is a set with no elements inside of it. Alright, the next one is a finite set. A finite set is a set with only a specific number of elements inside of it. Alright, so it has a very finite number of elements inside the set. The last one we have is an infinite set. Alright, an infinite set. This is a set that has an infinite number of elements in it. It goes on forever. It goes towards infinity, right? Or towards negative infinity. An infinite number of sets. All right, let's go on. Talk about types of numbers here. All right, the first type of number that we have are called natural numbers. All right, these numbers are like this: 1, 2, 3, 4, so on, all the way up. The next type of number that we have are whole numbers. Whole numbers. The difference between natural numbers and whole numbers is whole numbers include 0. And it keeps on going like that. The next type of number that we have are called integers. That should sound familiar, integers. All right. With integers, we now include negative numbers. So -4, -3, -2, -1, 0, 1, 2, 3, 4, so on. It goes all the way down as well. The next after that are rational numbers. Rational numbers are numbers that can be written as a fraction. So maybe 1/2. They could also be written as a decimals that can be written as fractions. So 0.33 or 33 hundredths. They can be whole numbers. They can be negative numbers. All right, they can be decimals that repeat themselves, like that. These are all types of rational numbers. And the rational numbers are numbers that can be written as a fraction. After rational, we have irrational. Irrational numbers are numbers that aren't rational. They cannot be written as a fraction. So maybe pi is an example of an irrational number. Or a decimal that goes on forever and does not repeat itself. Alright? Those would be examples of irrational numbers. The last type of number we have are real numbers. Alright? Real numbers are numbers that are rational or irrational. So both of these get clumped into real numbers. Let's look at this a little bit different way. One way we can look at this is start big and go small. So we have real numbers at the very largest spot. Alright? After real numbers, it gets broken up into two different types of numbers. We have irrational and rational. Broken up. Irrational numbers are all just irrational. Once we get inside rational numbers, though, we then start breaking them up even smaller. So inside rational numbers, we have integers. Inside integers, we have whole numbers. And inside whole numbers, we have natural numbers. All right? So you can see that natural numbers are right here. Inside whole numbers, you have whole numbers and rational numbers, or natural numbers. Inside integers, you have whole numbers and natural numbers. Inside rational numbers, you can then go down the line here. All right, so you can see how we can just kind of fit everything in. Example here, we're going to identify sets. All right, so 3/4, that fits inside the real set. It also, since it's a fraction, fits inside a rational set. At that point, though, it does not fit inside integers, so we're done. The square root of 7 is a real number, so it's in the real set. but the square root of 7 is not rational, which means it is irrational. So it fits inside the irrational set. 54. 54 is a whole number. It is a real. It's also rational. It is also a whole number, so it's integer. It also fits inside the whole numbers. And it is a natural. So 54 fits inside all of these sets. Talk about the difference of intersections and unions. Intersections can be written like this. A intersection B. What this tells us is that A and B and what they have in common. So do they both have 2's inside their sets? Do they both have 7's inside their sets? Unions are written like this. A union B. You can kind of see the U for union. This includes everything inside the set. Let's look at an example of this. Find that A, this would be intersection B, and A union B for each one of these. Alright? Let's make intersections blue and unions orange. Let's start off with the unions. A union B. Remember, this includes everything inside the set. You usually list them in order from least to greatest as well. So you can see A has 1, 2, 3, 4, and 5 inside the set. We already have 1, we already have 2, we already have 3, we already have 5, but we don't have 8, so we need to add that inside the union. Let's look at the intersection. This would be A intersection B. Alright? They both have 1's. They both have 2's. They both have 3's. 4 is not in B. 5 is in B. 8 is not in A. So my intersection would be 1, 2, 3, 5. And that's my intersection. Let's look at this one. A union B. Alright, 21. Here's 22. 31, 32. 41, 42. 51, 52. 61, and 62. Alright, these are all of the elements inside A and B. That's the union. Let's look at the intersection. Alright, 21 is not in either one. You can see actually that none of them have anything in common. So we can write that as that, or we could say that. This is an example of an empty set. It's an element that has, or it's a set that has no elements inside of it. Hope this all made sense. If not, you can feel free to ask me any questions later on. Have a good evening.